Hey guys, Miss Watson here. I hope you guys are all doing well. Today we're going to look at the next section, which is 11.8 samples and surveys. And what you're going to find in this section is that it's actually less about the actual calculations, and you're actually not going to do any calculations. There is going to be more reading, but this is really talking about an important part of statistics in learning how to take an appropriate sample. One of the reasons that we are focusing on this is because this is a part of the SAT. And want to make sure that you guys have some exposure to these types of questions. So let's go ahead and get started. Um, a little bit of reading here, right? Basically, right, an appropriate sample does not have to be totally random, but it must provide a good chance that the sample is representative of the population. Okay, so random sampling is usually one of the better types of sampling. There's a lot of different types. We won't go into that, but there are three rules to follow to try to have an appropriate sample. First, there must be some element of randomness. Okay. Second, the entire population must have a chance to be represented. And third, no biases should be entered into the process. So you guys have heard about bias, but let's just define it in terms of what we're talking about here. So bias is a systematic error introduced by the sampling method. Okay. And so a bias occurs when a part of a population is overrepresented or underrepresented. So that's an important key to know. And so it's something we want you to think about when you're working through these problems. Okay, so this occurs when a part of a population is overrepresented or underrepresented. I think I spelled it wrong there. Underrepresented. Okay. Um, So let's look at this example here. Does the sampling have bias? Okay, so we have a newspaper wants to find out what percent of the city population favors a property tax increase to raise money for local parks. Okay, says determine what, if any, bias each of the following sampling methods used has. Okay, so the first sampling method. Okay, a newspaper article on the tax increase invites readers to express their opinions on the newspaper's website. So another way to say this, right? People can go on the website and express their opinions about this tax increase that would raise money for local parks. So, what kind of biases potentially are here? So, um, bias depends on who visits the website, right? So, could be bias depends on who visits the website. Right? Not everyone reads the newspaper. Not everybody has internet access. Not everybody um, is going to visit this website. Um, also think that, let's say, proponents um, for one side, whichever side of the argument they're on, um, could rally friends to visit the website and express their opinion. Okay, so the bias really depends on who visits the website. And if it's a bunch of property tax owners that are against, right, a property tax increase, then they could rally all their friends to go on the website and express their opinions as well. Okay, second sampling method. Same topic here, right? Same topic here about the property tax increase to raise money for local parks. Okay, B says it. A reporter interviews people leaving the city's largest park. So the reporter is interviewing these people leaving the city's largest park, asking for their opinion. What percent favors the property tax increase to raise money for local parks? Okay, so this is actually called a convenient sampling. And again, you don't need to know that terminology. But the problem here is um, this may overrepresent park supporters, right? And that's because the interviewers at the park. So people who go to the park are people, probably people who like the park, who would probably vote for additional parks, right? So if I'm at the park, then I really like parks. And if you ask me, do we need another park? I'm probably going to say yes. So the bias here is that you may overrepresent park supporters, okay, because of the location. And I'll put a note there because of the location of the interview. So if you're thinking, well, what's a better option? Well, go to somewhere that's a public place, but doesn't have to do with the topic of park. So maybe go to the grocery store, right? People there have an opinion, they're invested in the city, but you don't know right away just from being in a grocery store whether or not you're in favor of parks. Okay. Next thing we're going to talk about is justifying conclusions. A lot of the questions that you're going to see on the homework have to do with what kind of conclusion can you make. Okay. And so it says here, in order for the results of a study to be generalized to an entire population, okay, random sampling is needed. So if you want to take the results of a study or survey that you do and you want to apply it to an entire population, it must be random sampling, which means that it cannot be assigned to specific people. It must be random. Okay. In order for a cause and effect relationship, okay, so this says for the results of a study versus cause and effect relationship, okay, to be established, random assignment of individuals to treatments is needed. And treatment just means here any factor that is deliberately varied in an experiment. Okay, we're going to see that in the next example. All right, see the keyword here is random. All right, let's just keep moving on. So this is a nice little table. I'm not going to read it to you, but I do think that this is a nice little summary chart of the type of random sampling or randomly assigned to treatments and when you can or cannot make generalizations. So basically, right, uh, results can be generalized to entire population. Conclusions about cause and effect can appropriately be drawn. So that is the I don't know if you want to call it the most favorable type of sampling. Okay, subjects selected at random and subjects randomly assigned to treatments. So randomly assigned to different factors. Okay, this is where results can be generalized to an entire population and conclusions about cause and effect can be drawn. All right, none of these others say both for them. Okay, if you're looking here, cannot be generalized, cannot be generalized. Okay, and then this bottom one, not randomly assigned to treatment. Conclusions about cause and effect should not be drawn, should not be drawn. Okay, so let's just go to examples because I think it's going to help if you look at an example here. All right, so it says Community Center offers a Spanish course. This year, all students in the course were offered additional audio lessons they could take at home. The students who took these additional audio lessons did better in the course than students who didn't take the additional audio lessons. Based on these results, which of the following is the most appropriate conclusion? Okay, so again, think about the sampling, the random sampling, if that occurred, and the random assignment to treatment. Um, okay, and the treatment would be here is whether they were taking the additional audio lessons at home. All right, so our options here, option A says taking additional audio lessons will cause an improvement for any student who takes any foreign language course. So I'm going to highlight a couple things. This says any student, says any foreign language course. All right, part B says taking additional audio lessons will cause an improvement for, again, any student, but this time it says a Spanish course. Okay, option C, taking additional audio lessons was the cause of improvement for the students at the community center who took the Spanish course. Okay, so kind of the key here um, is was the cause of improvement. Okay, and again, we're just talking about Spanish. All right, and then the last one here says no conclusion about cause and effect can be made regarding students at the community center who took the additional audio lessons at home and their performance in the Spanish course. So, again, this one says no conclusion. Okay, so couple things here, right? Um, and I highlighted those so you can kind of ask yourself a question. Let's just look at the first two options, right? It says any student. Can this be applied to any student? The answer here is no. It cannot be applied to any student because this was not representative of an entire population. Okay, so we look back up here, right? The subjects must be selected at random, and um, it must be generalized to an entire population. So this can't be true for any student. Okay, so we can eliminate. So we don't like any student. The other thing is this can't be applied to any foreign language because this was only for Spanish. So we definitely know it won't be A. Because B also says any student. Well, we only this was only taking into account the students at this specific community center. Okay, so we can't do it for any student. So then let's look at C and D. All right, C says taking additional audio lessons was the cause of improvement um, for the students, versus D says no conclusion about cause and effect can be made. So the difference between these two is in C, students were not randomly assigned. Okay, so I'm going to make a note down here. Students were not randomly assigned treatment. And in this case, treatment is taking audio lessons. It was made available, right? If we go back to the language here, all students in the course were offered an additional audio lesson. The students who took it, it wasn't randomly assigned. It wasn't like they said, of the students, we randomly assigned 50% of them to take the course. It was people who chose to do it. Okay, so that's kind of a hint to like questioning C. The other thing we want to do here is that we actually don't know the cause and effect. Okay, and this is the whole cause and effect part. And I'm going to say it again probably is association does not imply causation. Okay, we don't know that taking the additional audio lessons was the cause. There could be other factors. Okay, so we don't know if other factors played a part. So, um, an improvement. So we're going to eliminate C, and that leaves us with D. Okay, so no conclusion about cause and effect can be made. All right, video is going to pause. Go ahead and try this last question on your own. Okay, so hopefully you went through this and worked through the differences between the options here, right? A couple things here that I just want to go over is what I said just a little bit ago. Association does not imply causation. So two things can be associated, that there's a link, but that doesn't mean one causes the other. Okay. So if we use that, association does not imply causation, we should be able to eliminate D and C. Right. I'm just going to put it here, C and D, because it specifically says is caused by, is caused by. Okay. So that leaves us with A and B. Both say there's a positive association. Okay, so that's common between them. So what's the difference? The difference is here. A says the children in the United States versus B says in the city in which she works. And she talking about the So the correct answer here, hopefully you got it, was B. And this is because it can only be applied, the results can only be applied to the same population. Meaning it can be applied to the city, but not um, all children in the U.S., right? So That's the difference between A and B, so that's why B is your answer there. Okay, guys. Hopefully this makes some sense. And that when you look at the homework, I'm sorry, the practice problems, um, you're able to kind of think about these things that we talked about. All right. Thanks so much. If you have questions, please reach out to your teacher. Take care.